So we are presenting the EGRAPSA project, three of us, so I'm very sorry for any possible technical glitches and for the fact that I'm not a Greek specialist, neither Egyptian, I'm an Indologist with one leg in IT. So I would like to present you my view of the EGRAPSA project. So what is EGRAPSA project about? It is a very ambitious project that would like to provide a panorama of Greek writing on papyri and ostraka for over a millennium. And one of the milestones of this project is a precisely dated data set called HELDATE. I will now switch to our database and will show you live how it looks like. Okay, I have filtered now our database consisting of more than 2,000 papyri to 157 papyri constituting the HELDATE. What is NodeGoat? NodeGoat is a relational database. It is a paid product, and the license to this one is provided by the University of Basel. If we open any of the papyri, we would see a complete paleographic description with date provenance and even some statistics on the letter distribution, for example, like here. NodeGoat has some nice features. So I have now filtered it to the HELDATE dataset, which is a set of precisely dated Hellenistic papyri, dated sometimes to a day, which is quite amazing in this context. I would like to show you the visualization options that are included in NodeGoat. So if we click on the map, we can see it interactively. We can see how collection developed over the year. So let me just put 50 years per second and make it run. So you can see how papyri are distributed in time. Okay. Otherwise, we can also see if the data set is balanced. As for its chronology, we have a huge peak on minus 250 BC, but otherwise it's quite smooth. Okay. And finally, it will take some time to visualize. We can have a network visualization. I will just reduce complexity by removing authors, writing area, and surfaces. So here you can explore directly the connections by clicking on, for example, on the biggest point or the points of your interest. Let's take any of those. The database is fully visual and dynamic. By clicking on any visualization point, you would have access to all items having those features. So from here, we can navigate to any of those TM numbers and have, again, full description. Now, let me click on this one. So this database is organized hierarchically from TM to surface, means one side of digital papyri, to writing area, which allows us to separate pieces of writings by functions or by hands. But most important part are the cliplets. So we have here a golden data set of 100,077 something cliplets manually annotated. Database is organized in such a way that if you click on any of those, you can see more or less its real size in pixels. And each of them has a personal web page with a unique identifier and the full metadata. So each of these cliplets is perfectly citable, and it can be indefinitely expounded with our professional paleographist knowledge. However, what can we do with all those cliplets? How does it advance the aim of the project by providing panorama? This presentation does not help us at all. So I have created a small tool called Timeline, which allows us to visualize it more dynamically and in time. Now I will probably have to find it again. So here. This is a very basic tool, Python, consisting of two parts. So the first part takes the cliplets from NodeGoat and selects randomly 5 when there is a lot, and if there is less than 5 cliplets per letter, it takes them all. The next part of the script, also in Python, downloads the cliplets from the IIIF server and provides an HTML, CSS, and JavaScript visualization that you see here. It has been already pre-loaded pre-selected to display only the cliplets of the healthy dataset. Now we can select up to 3 letters. I just take random ones so that you can, explore how letters were written. So on the top you have dates, and the TM numbers are positioned one under each other. So if you see two very similar alphas, but mu's are not very similar, you can find the similarity and dissimilarity with these two. On the left, you have a number of filters. Let's play with norms. So let's take something from Oxyrhynchus. And the whole presentation changes. So we see much less number of the document. So this kind of tool constitutes like a middle layer of various possible visualizations. It would provide in the first version a link here to a tool which would allow us to read any precise historical document very close down to the text, which would be Palex. And on the other hand, we have a bird view visualization tool, which is being currently under development by Giuseppe, which by using machine learning provides the access to, let's say, macro type of those letters. So this is more or less the state of the project. And now I would like to pass the word to the future part of the project, represented by our two doctorants, Pedro and Ray. Thank you very much for your attention.
Thank you. Okay, we'll switch it here. Thank you very much. So I have a PhD project here integrated in the EGRAPSA project. I am studying the computer-assisted paleography of Greek literary papyri. And thanks to the work by Lavinia, by Olga, by Giuseppe, I can base my work on these tools, digital tools. And also I will explain. Oh, this is running by itself now. And I will explain also another digital tool developed by the project. So my project in an overview would be to build a corpus of the datable literary papyri, and the is maybe important. I would like to have ideally all datable literary papyri. Papyri with which carry literature are non-dated generally. So my problem is big. My corpus will be small, but I hope to have at the end around 300, 400 texts over the papyrological millennium, let's say, like from the 3rd BC to the 7th CE. And then I will analyze the paleography of those texts, trying to find ways to describe this analysis, and hopefully through typologies. I heard yesterday here Mark's talk against typologies. I would say I need typologies. We need them to explain our results, our observations. So I hope to find typologies, and that I can separate hands according to, let's say, the writer's skills or the writer's purpose or the writer's cultural background. Now, paleography of documents and paleography of literature is a kind of question that I have to ask myself every time, because I am studying the paleography of literature, whereas Lavinia made this data set of documents. So I have to ask myself: is documentary paleography and literary paleography really can we separate those? So we have examples of documents written in cursive hands and in literature written in book hands, what we could say of calligraphic hands. But this is not always the case. In fact, in this case, we have the opposite of we could think at the first sight. In the Katohoy archive, I will explain that in 1 minute. What we can say a cursive hand wrote a passage of Euripides, whereas in 200 years later or 300 years later, a decree was written in a very, very calligraphic hand. So I would say literary and documentary papyrology. These are not calligraphic categories. What we could try to do with this kind of typology or the of table to compare hands and to categorize them. So we would have the skillfulness, the skills of the writer on one axis and the speed of the writer on the other one. I want to propose this approach. In the unskilled part, you will only have lower speed, and then you will have beginner's hands. In the skilled part of the table, you can have faster hands to write documents, but professionally, so they can be fast and precise. And on the other hand, book hands, what we could call a book hand, is yeah, I am not trying to use cursive, informal, but actually that could be also a kind of term that could help us. That took the time to make ornaments, to detach the letters, or to make every letter always exactly the same way. The professional scribal hands would be also very regular, but joining letters to be faster, to be also more or less comprehended, but the focus is not there. And the beginner's hands would be just the irregular ones. For instance, we could describe them like this. And in view of the things that I heard yesterday and the other day, I could actually also propose an alternative to the speed, maybe writer-oriented or versus reader-oriented writers or scripts. Yeah, this is an open debate, and I'm very glad I could talk to some of you about this. Now, I will study some interesting cases in this papyrological millennium. I can't take the whole corpus and analyze it very carefully. So one of those case studies would be the Katohoy archive. The Katohoy archive is a very interesting set of documents. Katohoy, what does Katohos mean is could be for a whole book. I think there are books written only about this word. But let's say just that we have priests in some temple in Memphis, the Serapeum in Memphis in the 2nd century BC, that live there, that are like imprisoned there for some reasons, and actually unknown reason, maybe a religious one, maybe a political one. And we have in the core of the archive 2 Greek brothers that live among Egyptians. So it's also a bilingual archive. And we have many kinds of literary and paraliterary texts in this archive among documents. So we can date them very good, and we can extract the writer. We can recognize the writer in many cases. And as Willy Clarice said, this renowned paleographer and papyrologist, it is more or less the brothers' whole library, and not just a few stray scraps. And this is an exception in papyrology, to have the whole library of a person. This would be in an overview all kinds of literary and paraliterary texts that we can study in this archive. Now, let's go to the tool that Giuseppe De Gregorio here developed within the EGRAPSA project, Glyphics. Actually, 2 tools: a neural network that recognizes the letters, drawing bounding boxes around them, and then catalogizing there, or like finding the letter class they belong, and then the interface to see that result and correct it manually. So here you see the Timotheus papyrus, one of the first papyrus we tried on these glyphics, and it finds really everything that could be a letter, and so I took this very nice example of the coronis of this text. Coronis is our little bird, usually just a sign, but in this very old papyrus, maybe from the 4th century BC. it took really the form of a bird to mark the last chapter of the text. And as you see, it finds also 4 letters in the text. So we could say we have the mascot of Glyphics named Fofu. So it found a phi, an omicron, an epsilon, and another phi there. And it's actually pretty logical that he found it. So we say find please every letter you can. So once you corrected the annotation, you can have this kind of views. The annotation view, with, for instance, with all deltas in one papyrus. You can compare them to one another and have the intra-writer variation and study the ductus, for instance, of the letters. You can also have this more panoramic view of the papyrus when you can study this letter at the line level to see the bilinearity of the letter, or how it relates to the surrounding letters by ligatures, links, and so on. So in this Catofoy archive, at the end, I make manually from Glyphics big comparison tables and paleographical analysis tables, where I regard the ductus of the standard allographs, and also the variants of the most common version of one letter, the next variant. I explain it them for me in the most objective way I can. And then I study what I could call the cursivity of every letter. I could try to measure the cursivity of a letter if I see how many variants a letter has and how it relates to the surrounding letters by ligatures or links. And the ligatures could also be maybe subclassified in 4 categories: ligatures to the right, ligatures to the left, ligatures on both sides, and on 0 ligatures with non-transformative linking strokes. So a ligature would be a connection between 2 letters in which they share a stroke, or a movement, or a tone, or whatever we want to call them, so without lifting the pen. And a link would be, for instance, this, where the writer prolonged the last stroke of one letter to attach it to the next letter, but not sharing a stroke. And I also want to mention these primitives. I think they are very important. I also, thinking about yesterday's talk about the memory of the hand, I think there are some traces of this memory in the letters. For instance, the first stroke, linking stroke at the very end of the letter, this writer did this linking stroke. Or for instance, the first horizontal bar, the upper horizontal bar of zeta, xi, and tau had this hook, and so on. So to study and compare the letters. And lastly, I can show you an interesting case in this Catofoy archive, a syllabary that you could practice on yesterday on Papyrus. I can see now things that most editors skipped because of this very, very detailed analysis. And for instance, many people say, or not so many, the few people that edited and commented this papyrus said the writer went tired, become tired while writing these letters. So at the end, at the very last column, the letters were deformed. I think I can find 2 hands, just actually 2 people writing this syllabary, 2 students that in between column 18 and 19 just switched. And the second one took the calamos or brush or the tool and continued. And for instance, if I study this ductus with this order of strokes, first stroke, second stroke, third stroke, alpha in the first hand is done almost always in 3 strokes in this, I think, in this order and direction. And eta is also in 3 strokes in this way. Whereas the second hand has a total different way, or usual total different way to draw these letters. So now, moving from the appearance of a letter to the movement in the body of the writer, I pass the word to Ray, who is studying exactly this. Please.
Okay. Okay, hi everyone. My name is Ray. I was a PhD in artificial intelligence, actually my very first year, and I'm working for EGRAPSA project. So mainly my talk will be about how we apply the AI on our current project. So, the main question is what I'm doing at the Asian History department. Like I'm not study mainly about the languages, but actually what my main task is to find a reliable evidence to provide a context for the handwritings. For example, I need to identify which is the writers writing this kind of documents, or why these two characters is similar, or it does belong to maybe certain class of the societies, or maybe we should belong to one people. So, so the first task is actually very like straightforward, trying to extracting the trajectories from the offline images. And we did some tests with the current state-of-the-art method published actually by a team from Google. It's called Insight. So basically, this model can extract any kind of the handwriting trajectories, language-based, based on any kind of the papers. So you can see here, for example, you have the handwriting like this one. They can give us the trajectories, and even with some drawing or sketches, they also can give us some certain uh, reliable result. But the main problem is um, when we have dealing with a degraded data, or you have some untrained strip before, then the accuracy is become pretty bad. And also you don't have a ability to interact with the output of the models. So this is what like we did test with the papyrus data, even with the binarization form. The result was not very good, and currently there was no other way to interact with this kind of generations. So there was also another different characteristic between the Asian handwriting and the current modern one, which is the first one is the Asian handwriting is different. The way we write the characters, also the degradations. There was also the difference between the writer's gesture, different tool and material create a different referencing that create a constraint on the writings also. And this kind of information is not embedded into the AI models. So what we actually are interested to do is to try to integrate this kind of expert knowledge from the Asian expert to have the AI model to generate better trajectories. And we exploring a concept called writing intentions. So basically, okay, so basically, when input before doing the generation of the characters, expert will give the intention before doing any kind of interaction with AI model, and the output will be based on the intention plus the original image of the papyrus. So we have the concept of writing like this one. So we formulate the writing intention is as a combination between the intention and the individual capabilities equal to the final handwritings on the papyrus. So what we intention to do is first we create a synthetic samples of the handwriting that mimics the differences between people writing capabilities, and we train the model to remove this kind of factor bias. And therefore the output could be the writing intentions. We realize on the technique called kinematic theory for rapid human movement. Usually, this kind of technique is basically its application for the very difficult tasks such as the very signature verifications, for example, like this one. It's basically modeling the delay of muscle response time with respect to the time of initiations of the intention of the model. So everything will be theories with the velocity, with the log time delays of the neuron and the response time. And based on this kind of theory, we can actually separate the very complex signature or drawing into the fundamental structure, in which is starting from the initiate, the starting increasing the velocity and to the stopping of and changing direction of the writings. So we did that to do the augmentation for our data, given the input of the expert. We can augment the different type of writings based on the human capabilities, but the different difference rate. And we trying to remove this kind of bias using the similar approach of self-supervised learning, which is like the basic technique to do the large visual model at the current stage. And so the experiment, we collect some hypotheses for the Greek alpha letters. So basically, this is just for our proof of concept test experiment. So we utilize the Wacom IoT tablet to record the movement, and this kind of tablet can give us the precise trajectories and also the speed, velocity, spatial, and any kind of other data that needed to extract the writing intention for this. So this is our layout for the tablets that you use to record the data. And later on, we will have a workshop later on with to test with this kind of tablet. So so this is our inference flow from the papyrus. We have as one on the first input on AI models, and this the second one would be the expert knowledge, which is a sample of writing following the hypothesis of the expert. Okay, and this is the result for us. So for example, we can see here with the hypothesis on the top left of the screen, you have the input pattern and the green one. And the final one could be the output overlay of the trajectory, which is generated from the models and the original papyrus. So everything is followed to the hypothesis of the expert as the input. We also test about the hypothesis that is not matched with the original papyrus. For example, like this one is a very different one. It should not match with the images, but based on the intentions constraint to the AI models, it forced the hypothesis to match with the output of the images, but somehow the accuracy will not be high enough, so you can actually measure how much is matched with the current images given the hypothesis from the expert. We also tested with the some confusing pattern. For example, like this one, we can match 3 patterns, which is have the highest score. Is following like this one. So the last one should be the most fitted one because it's cover a lot or majorities of the area, while the other 2 is actually not very well. But in any case, can match pretty fine with the pattern. There was also the last one is about the degraded characters, because you're given a very solid hypothesis. It can also overcome the problems of the degraded or disconnected stroke, and it will give you the output that is still following the hypothesis. Okay, so our next step will be, I think it should be interesting. So what we expected to do next is to further develop, this is a small POC concept, but we develop an annotation tool that you can use it to either annotation at stroke level, which is like giving the instruction of AI model to generate the trajectory like this or that. You can also use this tool to query the characters from a very big database, so you can see which character is similar to what we expected as the input of the expert. And the last one is to recover the writing characteristics on the papyrus. So that is the end of our presentation. Thank you so much.